students, my name is Chaitanya, Physics faculty at Shakthi International School. Today in this video we are going to learn about an important topic called variation of G due to rotational motion of the earth of chapter gravitation from class 11. Okay, we are going to analyze variation of G due to rotation of the earth. Rotation of the earth. We know the value of acceleration due to gravity, where g is acceleration due to gravity. It is changing because of few factors. That means it will be changing because of shape of the earth. It is going to change because of height. It is going to change when there is a change in depth, and it is also going to change due to the rotation of the earth. In this video we are going to concentrate on rotation of the earth, change due on in gravitational field due to rotation of the earth, rotational motion of the earth. Very good. Now you know the formula for acceleration due to gravity is g into mass of the earth divided by r square. Okay, given if the object is on the surface of the earth, if this is a position of the object, then the acceleration that this object experiences will be in downward direction. That acceleration due to gravity will be written as, since the radius of the earth can be taken as re, in place of r, that is the distance between the centers of those two objects, we can write that one as g into mass of the earth divided by re square as acceleration due to gravity. Now, since this acceleration due to gravity is only due to the gravitational force, and the object when it is kept on the surface of the earth is already in rotational motion. The earth is moving with an angular velocity omega. If you want to find the angular velocity omega, you can use a general formula that it is covering 2 pi r distance in a time period t. Okay, you can understand how fast it is moving. Okay, you know the time period of the earth, that is 24. You can calculate this, the angular velocity of omega, by substituting the values. It is covering 2 pi r perimeter, okay, in time period time. So 2 pi into r, radius of the earth is 6 into 10 power 6 meters divided by time period. You can use time period, sorry, you will not be getting here at radius 2 pi by t. Omega, general formula of omega is 2 pi by t, right? You will be just simply substituting that omega formula, which is 2 pi by t. Okay, now that time period, you know, 2 into pi in general form 22 by 7 or 3.14. If you are substituting 22 by 7 divided by 24 into 60 into 60, you will understand the value of omega is very small. If the value of omega is very small, okay, the angular velocity is very small. If the angular velocity is very small, we have to analyze what is its effect on the rotation of the object. Okay, so let me draw it here. Let's say this is our earth, and earth is of a spherical body. We are having the radius of the earth as r e. Let's say we are standing somewhere here. That means the location of the object from the horizontal can be taken at an angle theta. So the object which is standing here or kept here is doing a circular motion in this circle of radius small r. Now this object, any object which is performing circular motion, will be experiencing centrifugal force or centripetal force. In this case, if I am taking it as centrifugal force, we can write that one as mr omega square, where omega is the angular velocity. There will be a net acceleration due to gravity which is acting g towards the center of the earth. Now due to this is a force. Because of this force there is an acceleration in this direction, that is centrifugal acceleration, can be written as r omega square. So we are having two vectors. One is in this direction and the other one is in this direction, which is r omega square. Now the net acceleration due to gravity G effective will be somewhere here. So how do we find acceleration due to gravity? Net acceleration due to gravity. We know we can use a general vector addition formula. That means G effective can be written as under root of G square plus r omega square whole square plus 2g r omega square. We have to write what is the angle between those two. Those two vectors, what is the angle between them, we have to write. See, if this is angle theta, this also will be angle theta, and this can be written as 180 minus theta. So the angle between g and r omega square is 180 minus theta. So if you are substituting that 180 minus theta in terms of cos here, cos of 180 minus theta, since cos is in second quadrant, cos is negative, we can change this expression into under root of g square plus r square omega power 4 plus 2gr omega square cos theta. And when it is becoming cos theta, I have to change this sign from positive to negative. So this is the general value you will be getting. Now further, if I am writing this one as G effective is equal to G square, we know that omega is very small. If omega is very small, then omega square will be much smaller, very small, and omega power 4 will be negligible. That means I am approximating the value of omega power 4 completely 0, so I can neglect it completely. This is completely becoming 0. So under root of G square minus of 2g r omega square cos theta is there. Now we know that this value is very small. If I am taking g square common out, that means since it is in under root, g will be coming out of it, can be written as 1 minus 2 r omega square cos theta divided by g. So this can be further written as g into under root 1 minus, I can write that under root function in the form of 1 minus 2r omega square cos theta divided by g whole power 1 by 2. So now using binomial theorem, that is 1 minus x whole power n can be written as 1 minus nx, I can write this function as g into 1 minus 1 by 2 into 2r omega square cos theta divided by g. So these two gets cancelled. We will be finally getting a value when g is multiplied inside as g minus g into r omega square cos theta divided by g. So these two gets cancelled. You can write g minus r omega square cos theta. This is the g effective acceleration due to gravity, how it will be changing with respect to the rotation of the earth. Now we can analyze with respect to positions. Let's say we are at equator. At equator, the value of angle theta is going to be 0. At the poles, the value of theta is going to be 90 degrees. Now if you are substituting in place of g effective at equator, you can write it as g minus r omega square cos 0. That will give cos 0. That will give g minus r omega square. Whereas at poles, if you are writing, then it will be g minus 0. Since cos 90 is 0, so that means acceleration due to gravity at the poles due to rotation of the earth is greater than acceleration due to gravity at equator. So that's how we have to analyze this condition. I hope you understood this. If they have given any other particular angle, you can substitute that angle accordingly here, but remember that this angle theta is with the horizontal. Okay, so hope you have understood this well. We'll meet in the next video. Thank you.